So once the auction ends, we now have two functions that are executed. And you might notice that we have these two functions, claim asset and claim bid, rather than just saying, when the auction ends, do this thing. And the reason we have explicit functions versus just say waiting for the auction end is because there's no concept of like event driven functions on Algorand. In order for something to happen on chain, someone has to explicitly call the contract. So in our case, once the auction is over, we want people to be able to explicitly claim the bid and claim the asset. So here in our claim bid function, this is an external function. And what it's going to do is first make sure that the auction has ended. So we're making sure our global timestamp is greater than our auction end. And in this example here, I've commented it out because we're going to be doing some automated testing and we're just always going to assume that our auction has ended when we call this method. Right now, the Algorand Inc. is actually working on a method to automatically spoof the timestamp so we don't have to comment this out. But until that gets released, for now, we're just going to comment out this time check. But if we were to deploy it on mainnet, what we want to do is make sure that no one can call this method until the auction is over. And all this is basically going to do is going to pay the global creator address. So whoever started the auction, the amount of the highest bid. So at the end of our auction, we have some amount of algo locked on the contract corresponding to the highest bid. And so when we call claim bid, we want all that algo to go to the creator. And then the complementary function, claim asset, basically does the same thing, except it sends the asset to the winner. So what we're doing here is saying this is an external method called claim asset. We're passing in our asset and our asset creator. And again, we commented out our time check, but in production, we would check to make sure that we actually ended the auction. And then we use the inner transaction to send the asset from the contract to the winner. So here, specify an asset transfer, set the fee to equal to 0. So much like before, our inner fee will be 0, but our outer fee should be double. And then we're going to call or specify our transfer asset as the asset we have saved in our global state. The amount will be the amount we have saved in our global state. The receiver will be the highest bidder. And our asset close to transaction will be the creator address. Now, what this basically means is that we are completely emptying out the contract's balance of this asset. And the reason we're doing this is twofold. One, if we're bidding or auctioning for a fungible asset, what we want to do is make sure that the contract doesn't have any of that fungible asset left over. So the amount we're sending is the ASA amount, and that's the amount that we start the auction with. What if throughout the duration of the auction, someone accidentally sends it some additional tokens, then that amount won't get sent to the winner. Instead, it'll just be sent back to the asset creator. And the reason why we're specifying the asset creator is because they're the only account on the network that is guaranteed to be opted in to the asset. And so we want to make sure when we call asset close to, it's always a count that's guaranteed to be opted in. And the reason why we're closing to the asset creator rather than our highest bidder is because we don't want people to game the system and people think that they're bidding for some amount of the asset, but then the creator will add more asset and then the winner gets more asset than everyone else thought they were bidding for. So we're always closing to the creator address. And so if we take a look at our arguments, we have our asset and we need to define this as an API asset because we're going to be sending a transaction, transferring the asset. So again, anytime we work with the asset app or application, we have to predefine it. So we're defining what asset we're doing. Then our asset creator is going to be whatever account created the asset. In reality, it's whatever account is opted into the asset that we specify in our front end, but we want it to generally always be the creator. And then you might notice that earlier we had this previous bidder, but we don't have that here. And the reason we don't have that here is because we expect the claim asset function to be called by the highest bidder. And in that case, the highest bidder doesn't need to specify their account in the arguments because the color of the account is always available to the AVM. And so, because there's no authorize here, if someone other than the highest bidder were to call this, you would also need to specify the highest bidder account to the AVM, tell it that we're going to be accessing it. But in our case, we don't need to explicitly do that since we expect the caller to be the highest bidder. So that's our claim asset function. And one common question is, why don't we do both of these things in one function? Why don't we just have an auction function that does both of these? And the reason is because this claim asset function is entirely dependent on whether the highest bidder is currently opted in. So if the highest bidder is not opted into the asset, that means that this inner transaction will not be able to send. Thus, this claim asset method will fail. If we tie together our claim bid and claim asset functions together, this basically means the auctioneer, so the person that created the auction, will never get paid out until this person opts into the asset. So you could have someone maliciously win the auction and then never actually opt in. And so now, in that case, they basically lock both the asset and that amount indefinitely into the contract. Okay. And then finally, our delete method. So this is very similar. If we go all the way up top here, we have our .create method and with the .create decorator. And here we have our @delete method, the @delete decorator. And also go ahead, make this bare. What we're basically doing here is closing out all the remaining balance in the contract so it can be deleted. And so what we're doing is sending an inner transaction, we're sending a payment, setting the fee to 0 so it can be covered by the outer transaction, sending the receiver to the global creator address. So if someone accidentally sends the contract some algo without sending a bid, then what this basically means is at the end of the auction, the creator will get that algo back. Then we have our close remainder to, and we're closing to the creator address. And what this does is if we didn't have this field, this would only allow us to send however much is left in the contract up until 0.1. And the reason being that in order for an account to be allowed on the ledger, it has to hold 0.1 algo. And if you try to go below that, the ledger will complain, say, hey, you can't go below 0.1. But the exception is if we call this close remainder to field or specify the close remainder to field. What we're basically doing here is telling the ledger we want to be able to close or send this remaining 0.1 algo and send that balance to the creator address. And then we're specifying the amount as 0 because this close field will automatically get whatever the balance is and transfer that amount. So high level summary here, we have our state that defines a couple of key value pairs, our highest bidder, auction end, highest bid, ASA amount, and ASA. We initialize our app, have a method for creating it that initializes our global state, a method for opting into our asset, a method for starting or for opting the contract into the asset, a method for starting the auction, a method for placing bids, and then a claim bid method and claim asset method, and a delete method for once the auction ends. So that's the core logic of our contract.